students of grade 3 secondary. Welcome to our method program. Today we have calculus. Our lesson today is applications on maximum and minimum values. Now, let's start with the first application. Example, the height of a cylinder which has the greatest volume placed inside sphere whose radius lengths are equals 2r over root 5, 2r over root 3, 2r or equals 2 root 3r. We know that r squared equals r power 2 minus y power 2 and h equals 2y. R is the radius of the cone and the cylinder, and r small is the radius of the sphere. And h is the height of the cylinder. Now, what is the volume? The volume is of the cylinder by r squared times h. Area of the base times the height. The base of the cylinder is circle, and we know that the area of the circle is by r squared. Multiply the height of the cylinder h. Now we have two variables, r capital and h, the radius of the base of the cylinder and the height of the cylinder. And we know that h equals 2y and r squared equals r power 2 minus y power 2. Then the volume V equals by multiply between two brackets r power 2 minus y power 2 times the height, which equals 2y. Then the volume of the cylinder equals by between two brackets 2r power 2y minus 2y power 3. Now we have a relation between the volume of the cylinder and the radius length of the sphere. The first derivative of the volume V dash equals by the constant between two brackets the derivative of 2r power 2y. We know that y is the variable, but r, which is the radius of the sphere, is a constant. Then the derivative of 2r power 2y equals 2r power 2. And the derivative of negative 2y power 3 is negative 6y to the power 2. Now, the second derivative of the volume, which is v double dash, equals by the constant, and the derivative of 2r power 2 is 0 because 2r power 2 is a constant value, and the derivative of negative 6y power 2 is negative 12y. Then v double dash equals negative 12 by y. Now, what is the critical point? To get the critical point, put the first derivative v dash equal 0. Then the expression by multiply between two brackets 2r power 2 minus 6y power 2 equals 0, and we can get the value of y power 2 equals 1 over 3r power 2, and y equals positive 1 over root 3r, or y equals negative 1 over root 3r. We know that y is a positive value, then y equals negative 1 over root 3r is refused. Then the value of y equals 1 over root 3r. Now, by use the second derivative test, we can substitute in the second derivative v double dash when y equals 1 over root 3r. Then the value of the second derivative equals negative 12y multiply 1 over root 3r, which is a negative value. When the second derivative equals 0 at y equal 1 over root 3r, then the function or the volume is as great as possible when y equals 1 over root 3r centimeter. Now the question: the height of the cylinder which has the greatest volume placed inside a sphere whose radius lengths are equals. The height of the cylinder h equals 2 over root 3r. 2 over root 3r is the height of the cylinder which has the greatest volume placed inside a sphere whose radius length equals r. Then the right answer is the letter B. Another example. In the given figure, if AB equals 20 centimeter, prove that the area of the triangle OAB is maximum when A equals B. The given figure represents a straight line passes through the 2 points A and B. The point A lies on x-axis. Then the value of y equals 0 and the value of x equals a. And the point B lies on the y-axis, then B is 0 and B. The length of the hypotenuse AB equals 20 centimeters. Then, by using Pythagoras theorem, then a power 2 plus b power 2 equals 20 power 2. 20 power 2 equals 400. Then a power 2 plus b power 2 equals 400. What is the value of b? b equals square root of 400 minus a to the power 2. Now, the area of the right angle triangle OAB. The area of the triangle. The function or the relation between the area of the triangle and one of the two sides of the right angle is a equals half a multiply square root 400 minus a to the power 2. Now, a dash equal the first derivative of the area. A dash equals product of two functions. Half a multiply root 400 minus a to the power 2. The derivative of the function half a is half multiply square root of 400 minus a to the power 2 plus half a multiply the derivative of the square root of 400 minus a to the power 2. The derivative of the square root 400 minus a to the power 2 equals the derivative of the function inside or under the root, which is negative 2a over twice a root or double the root. Then the derivative of square root of 400 minus a to the power 2 is negative 2a over 2 multiply 400 minus a to the power 2. Then we can simplify 2 from the numerator and the denominator. Then a dash equals half multiply square root 400 minus a to the power 2 plus half times negative a times a, which equals negative a to the power 2 over square root of 400 minus a to the power 2. Now, to get the critical point, we put a dash equals 0. The first derivative equals 0, then half multiply square root of 400 minus a to the power 2 equals half multiply a to the power 2 over square root 400 minus a to the power 2. We can cancel half from both sides and cross multiplication, then 400 minus a to the power 2 equals a to the power 2. Now, 2a power 2 equals 400, then a power 2 equals 200. And the square root of a power 2 equals 10 root 2. At a equals 10 root 2, we have number line. A equal 10 root 2 is a critical point. Then a dash, or the area, derivative of the area, which is the first derivative of the function, equals 0 when a equals 10 root 2. And in the open interval negative infinity and the 10 root 2, if double dash x is positive value, then the function is increasing on this interval. And on the open interval a and the infinity, if double dash x is a negative value and the curve of the function is decreasing, then the function or the area is maximum when a equals 10 root 2. When a equals 10 root 2, what is the value of b? We know that b equals square root 400 minus 200. Then b equals square root of 200, then b equals 10 root 2. Then the area of the triangle OAB is maximum when a equals 10 root 2 and b equals 10 root 2, then the value of a equals the value of b. Another example. If the perimeter of circular sector is b, prove that its area is to be maximum when its radius r equals p over 4. P is the perimeter of a circular sector. We know that the perimeter of the circular sector, P, equals L plus 2R. L, the length of the arc, and the R is the radius of the circle of the circular sector. Then, when P equals L plus 2R, then the length of the arc L equals P minus 2R. We know that the area of the circular sector equals half multiply L multiply R. Half LR equals half P between two brackets, P minus 2R multiply R. Then the area of the circular sector equals half PR minus R to the power 2. This relation between two variables, the area of the circular sector and the radius of the circular sector. Now, what is the critical point? To get the critical point, we find first a dash, the first derivative of this function. Derivative of half PR is half P, and the derivative of R power 2 is negative 2R. Put a dash equals 0, then the radius equals P over 4. Now we can use the second derivative test. the second derivative a double placed inside a sphere whose radius length is 9 centimeter. Then y power 2 equals r power 2, or 81 equals y power 2 plus r power 2, because we have right angle triangle. Then y power 2 plus r power 2 equals 81. Then r power 2 equals 81 minus y power 2. What is the length of the height of the circular cone? The height of the cone is 9 plus y. Then h equals 9 plus y. Now, what is the volume of the cone? V equal third area of the base multiplied the height. The base of the cone is a circle. Then V equal third multiply by r squared multiply the height h. Now h equals 9 plus y, and r power 2 equals 81 minus y to the power 2. Then the volume V equals third by multiply between two brackets 81 minus y to the power 2 multiply between two brackets 9 plus y. Now V equal third by between two brackets 81 y minus y power 3 minus 9 y power 2 plus 729 by expand the brackets to simplify the expression. Then V dash, the first derivative of the volume, equals third by is a coefficient and constant, multiply the derivative of 81y is 81, and the derivative of negative y to the power 3 is negative 3y to the power 2, and the derivative of negative 9y power 2 is negative 18y. Now the second derivative v double dash equals third by multiply the derivative of the expression between the two brackets is derivative of 81 equals 0, and the derivative of negative 3y power 2 is negative 6y, and the derivative of negative 18y is negative 18. Now, to get the critical point, we put v dash equal 0. When v dash equal 0, then third by multiply 81 minus 3y power 2 minus 18y equals 0. By factorize the expression, then y equals 3 or y equals negative 9. Y is the length, then negative 9 is refused. Now we can use the second derivative test. When y equals 3, then v double dash 3 equals negative 12 pi. Negative 12 pi is a negative value. Then the volume is as great as possible when the value of y equal 3 centimeter. And the height of the cone, which equals h, equals y plus 9, or 3 plus 9 equals 12 centimeter. Then the height of the cone equals 12 centimeter. Another example. Find the two dimensions of a rectangle which had the biggest area, and it can be drawn inside a triangle whose base length is 16 centimeter and its height is 12 centimeter, such that one of its sides lies on the base of the triangle and the two vertices of the opposite side lie on the two other sides of the triangle. Now we draw a rectangle inside a triangle such that the one base or one dimension of the rectangle lies on the base of the triangle and the two vertices of the other base lies on the two sides of the triangle, and the base length of the triangle is 16 centimeter and its height is 12 centimeter. Now, to calculate the biggest area, we model the problem according to the given data and constraints. Determine the variables or the unknowns by letting the rectangle width x centimeter and its length equals y centimeter, and the area of the rectangles is equals a centimeter power 2. The relations among the variables, mathematical model, area of rectangle, area equals a multiply x times y, or multiply the two dimensions of the rectangle, length times width. Putting the mathematical model in one variable if possible. From similarity, then y over 16 equals AD over AB equals 12 minus x over 12. Then y equals 4 over 3 multiply between two bracket 12 minus x, and the x belongs to the closed interval 0 and 12. Now, the area of the rectangle A equals 4 over 3 x multiply 12 minus x. Here, the area is the function f of x. We have one variable, the variable or one unknown x. X represent one dimension of the rectangle, the width of the rectangle. Solving the mathematical model by differentiating both sides of the relation number 2 with respect to the variable x, or the width of the rectangle. Then, the first derivative f dash x equals 16 minus 8 over 3x. And the second derivative f double dash x equals negative 8 over 3. Now, to get the critical point, we put the first derivative f dash x equals 0. Then x equals 16 multiply 3 over 8, then x equals 6. And by using the second derivative test, f double dash x when x equals 6 is a negative value, then the area A has an only critical point when x equals 6, and the second derivative is always negative, then this critical point gives the absolute maximum value of the function. The function A has an absolute maximum value when x equals 6 and y equals 8 over 3 multiply between two bracket 12 minus x. X equals 6, then the value of y equals 8. Then the rectangle has the biggest area when its two dimensions are 6 centimeter and 8 centimeter. And by this example, we come to the end of our math program today. And till we meet again, it's goodbye.